Aqueous solutions. So water is known as the universal solvent because it is capable of dissolving so many things. And we'll talk about why it's capable of dissolving many things in a couple slides here. So a couple of vocab words because we take so many vocab quizzes. A solution is a homogeneous mixture that consists of a solute dissolved in a solvent. An example is salt water. A true solution is a stable mixture. That means there's no settling or filtering out. A solute then is a substance that's dissolved, like salts, and then the solvent would be the dissolving medium, such as the water. Water is a pretty popular, if that's a right word there, a pretty popular solvent. An aqueous solution then is water that contains one or more dissolved substances. The dissolved substance can be either a liquid, solid, or a gas. So the dissolving process, water typically dissolves most ionic compounds and then any polar molecules. Non-polar molecules such as grease and oil will not dissolve in water. There's a pretty popular rule saying that like dissolves like, meaning polar substances dissolve polar substances, non-polar substances dissolve non-polar substances. So the reason why water won't dissolve oil or grease is because water is polar and grease or oil is non-polar, and so therefore they cannot dissolve one another. Solvation is the process that surrounds the individual ions by solvent particles. That's what is being shown in this diagram right here. In this first one, we just have a regular crystal structure. It looks like a table salt. And when you place the table salt in water, the partially negative oxygen ends of the water molecules will align themselves with the positive sodium ions, and then the negative ends of the chlorine will align themselves by the partially positive ends of the water molecule. And so when water dissolves something, the solute will change to the state of the solvent. So in this case, that solid salt will melt or become a liquid. Hydration is the process of the solute particles being surrounded by water molecules and being arranged in a specific manner. This specific manner is the aligning of the positives and negatives, because like charges repel and opposite charges attract. So that would be this setup here and here. This stabilizes the aqueous solution. It prevents the positive and negative ions from coming back together. Since sugar is a molecular compound, it's held together by intermolecular forces. So when the water dissolves the sugar, the attractive forces are disruptive. The covalent bonds will not break. So the water will surround one single sugar molecule. So the sugar molecules are usually clumped together, but the water will break them apart. Insoluble compounds, we have ionic insoluble. This is when the attraction between the ions and the crystal lattice are stronger than the attraction of the water molecules. So those water molecules aren't a strong enough magnetic or negative positive force to kind of tear it apart. The nonpolar compounds will not dissolve in water because the attractive force between the particles are too weak to break the bonds between adjacent water molecules. Miscible is just liquids that dissolve in one another in all proportions. Immiscible is liquids that will not dissolve in one another. Like I said, the general rule here is like dissolves like. Electrolytes and non-electrolytes. Electrolytes are compounds that conduct electric currents when dissolved in water. Non-electrolytes will not conduct electric current. In order for an electrolyte to function, the ions have to be mobile and be able to move from one electrode to another. So in this diagram down here, here's one electrode, and here would be a second electrode. So the reason this light is on is because you have electrodes moving between the two. to kind of complete the circuit. Insoluble ionic compounds are considered electrolytes if they're first melted, not in the solid state. They have to be in that molten or that liquid state. Non-electrolytes will not produce ions when dissolved in water, and so since there's no ions to move, the light will not turn on, that circuit will not be completed. Dissociation is the process of separating ions that occur when a solid ionic compound dissolves. So we can show that in forms of chemical reactions. So we have our table salt, and it's going to break apart into the sodium ion and the chlorine ion. We know that it's dissociated because of the AQ written behind each ion. So that's indicating that it started as a solid and then it was placed in water and it dissociated. These other two are also examples of dissociation. All right, a strong electrolyte is a solution in which the majority of the dissolved solute will exist in ions. An example here is hydrochloric acid. And a weak electrolyte is a solution in which only a small fraction will dissociate. Nitrous acid does that. All right, and that is that for aqueous solutions.